Part 1. The Newman projection on the left has even spacing between groups on the front carbon and the back carbon. The Newman projection on the right has groups right in front of other groups. I hope it is clear that this one is the one called eclipsed and the other one is called staggered. Looking at the front carbon here, the A is directly above my head. So if I had to draw it here, I'd put it there. If I was looking at it here, I'd draw it there. B is definitely below horizon and on the right. There's only one bond that fits here. My right hand would be sticking out of the page if my eye was in the page like that. Oops, that is B. And the B would be to my right here. This time, my right is behind the page. Try putting your head to the page to verify that. The C would be to my left and slightly down. That represents this position, and the wedge sticking to my left from this side. The B prime is on the back carbon, sticking directly downwards, not to my right, not to my left. That represents this position. The A prime is definitely to my right and upwards. From this side it would be a wedge. From this side it would be a dash. My apologies. B prime directly downwards on the back carbon. A prime to my right. A prime to my right. B prime directly down. C prime is clearly to my left and slightly up. Looking at it this way, this would be my left. And looking at it this way, this would be my left. There you go. There you go. Staggered from the left, staggered from the right. Let's pick it up a notch here. A directly above my eye here, directly above my eye here on the two eclipses from each side. B to my right. B to my right. C to my left. C to my left. A prime directly behind A. Both conformations. C prime directly behind C. Both conformations. B prime directly behind B. Both conformations. Before we proceed with the test type question down here, let's look at this sentence up here. Let B represent the bulkiest group on each tetrahedron. Remember, bulky means branched very close to the tetrahedron, like we saw with chairs. Immediate branches being the bulkiest. So a sec-butyl would be bulkier than an isobutyl, because a sec-butyl has the methyl branched immediately, an isobutyl has it branched further away. Let's do the problem. Down here, we're instructed to have our eyeball looking from the right side here. Carbon 6 will be in front, carbon 7 will be the hidden carbon. Directly above the eye is this group here. I always start with that group. The the Newman projection we need is this one, where on the front carbon I have a group directly above the eye. That is this group here. And this would be on my right side. A dash goes behind the page. and the H would be on my left side. Now, on a test, it takes a long time to type that out, or write that out. No typing on the test, please. So I would prefer if you use the stick figures when at all possible. So going to carbon 7, draw the bond that's not the wedge, not the dash. That's this bond. Ask yourself the question, is that bond straight down, slightly to the left, slightly to the right, up, slightly to the right, slightly to the left, up? The answer is just straight down. It's a 5-carbon chain. Easiest way is just to draw it. 1, 2, 3, 4, 5. Doesn't have to look pretty. Which hand is grabbing the isopropyl group here? Clearly the right hand, because it's on a dash. Everything to the right is on a dash, looking that way. And the tert butyl group is on the left. Very good. Part B wants you to draw the least stable Newman conformation. Using our short form from above, B would be the bulkiest bulkiest group on the front. Iodine being quite a massive atom makes that the B group. This just has 3 carbons and then a 4th C and then the branches, which is far away from the attachment. And on the back, B prime would be the tert butyl. On this example, I believe part C is done already. Part C asks for the most stable. Looks like I got the box with that. So, when you're lucky, one of them's already the least or the more stable. How would I draw the structure for B? Pick one of the carbons. And I need to have the B prime right in front of the B. Maybe if I rotate the front carbon 180 and move it here, I will have the least stable structure. Because now the B is over here. Maybe if I color this lighter. Then it's easier to see. There you have it. We've solved the problem. 9 points. Let's attack the next problem. We are told we have to look at the molecule from this direction. 6 in front, 7 behind. I think the Newman we're looking at looks like this, where there's a group straight below my eye, that being a methyl on 6. And behind that is a straight chain from 8 to 11. So let's put the groups that are either straight down or straight up first. We've already got a methyl on the end of the green. Let's finish the chain that goes 8, 9, 10, 11 on the back. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Maybe I miscounted. 8, 9, 10, 11, 12, 13. 8, 9, 10, 11, 12, 13. Is this a wedge, is this dash a bond to the left or a bond to the right? Behind the page is clearly to the left of my eye. So that would be this group here, a 3-methyl butyl group. 1, 2, 3, 4. And I apologize, it's a 2-methyl butyl group with a methyl right there. On the front carbon, we have an isohexyl. One, 2, 3, 4, 5 with a V. 1, 2, 3, 4, 5, 6. I seem to do that a lot, don't I? 1, 2, 3, 4, 5. I'm always forgetting the first carbon was already drawn for me. On the test, it won't be drawn for you. You will be starting from scratch. On the back carbon, there's a fluorine here to my left. Unfortunately, I made a mistake that I hope you're not making. I said I was going to draw this to the right. I drew it to the left. Bite the bullet. 2, 3, 4, 5 with a V. Directly behind that is a sec-butyl. Now, to my left, a fluorine off the back carbon. Bear with my mistakes. To my left on the front carbon is the 2-methyl butyl. Let's verify everything here. Things got a little confusing there. On the front carbon, directly below my eye, should be a methyl. Front carbon, straight down, methyl. On the front carbon, to my left, should be the 2-methyl butyl. On the front carbon, to my left, should be the 2-methyl butyl. On my carbon to the front carbon to the right should be the isohexyl. Isohexyl to the right. On the back carbon, to my left, fluorine. Fluorine. On the back carbon to my right, sec-butyl. I think I drew sec-pentyl. 1, 2, 3, 4, 5. On the back carbon straight down, which is the one I drew first, the one I drew correctly, should be a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Worth the wait. All right. Is this the worst or least stable structure? Well, it's certainly not. Is this the best or least stable structure? Well, it's certainly not the best when it's eclipsed. But it's not the worst because it's not the worst eclipsed. Front carbon has to rotate how many degrees to be the worst structure? Well, let's put the B's on. Bulkiest on the front carbon. This one has a branch on the second carbon. This one doesn't have a branch till quite further away. This one doesn't have a branch at all. Bulkiest on the back carbon. Branch right away. Fluorine is tiny. It's like a methyl without the H's in size approximately. And this has no branch at all. So it looks like a 120 degree rotation on the front carbon. Should do the job. Looks like that. Got bulky on bulky. Same story going to the next box. 180 degrees away from the worst is the best. The bulkiest groups will be anti. As in our previous example, the bulkiest groups were anti. Swing this guy out of the way a little bit. And there you have it. I'm going to swing that down here a little bit, just for clarity. Congratulations, 18 points of fun.